Imagine an object the size of Mount Everest, made of dirty ice and ancient rock, flying through the solar system at a speed that would make a jet plane look like it's standing still. Now imagine that this object has a core so dense that, if it hit Earth, the energy released would be equivalent to billions of atomic bombs going off at the same time. It wouldn't just be an explosion. It would be the end of an entire geological era. This isn't theory. It's what happened 66 million years ago. And it can happen again. The comets that cross the night sky with their majestic tails aren't just beautiful. They're harbingers of cosmic destruction. They carry with them the frozen memory of the birth of the solar system, but also the potential to wipe out entire civilizations in a matter of hours. How can something so distant, so silent, represent such an absolute threat? How can we sleep peacefully knowing that the darkness of space hides projectiles that have been traveling for millions of years, just waiting for the right moment to cross our path? Here's the truth. There is a pattern, a cycle. And the more we look at the sky, the more we realize that we are not safe. We never were. Let's go back a bit. After all, what exactly is a comet? For centuries, comets were seen as omens, divine signs of war, famine, or death. Even brilliant thinkers like Aristotle believed that comets were atmospheric phenomena, something like lightning or storms. It was only in the 17th century that Edmund Halley realized that those bright visitors came back. They had orbits. They were predictable. But being predictable doesn't mean being safe. A comet is basically a ball of ice, dust, and rock left over from the formation of the solar system 4.6 billion years ago. They live in the most distant and frozen regions of space, places like the Oort cloud and the Kuiper belt, until something disturbs them. A star passing nearby, the gravity of a giant planet. And then, suddenly, they start falling toward the sun, and some of those paths cross Earth's orbit. When that happens, the question stops being if and becomes when. Have you ever stopped to think about why the dinosaurs disappeared? The most accepted answer involves a 10-kilometer wide asteroid that hit Mexico. But asteroids aren't the only danger. Comets can be even worse. They come from farther away. They travel faster. And because they spend most of their time frozen at the edges of the solar system, we detect them too late. So how does this invisible threat work? How can a dirty block of ice put an end to everything? Let's build this step by step. First, size. Comets vary a lot. Some are just a few meters across. Those burn up in the atmosphere and turn into harmless meteors. But others are monstrous. The comet Hale-Bopp, which crossed our skies in 1997, had a core 40 kilometers wide. 40 kilometers. That's bigger than the island of Manhattan. If something like that hit Earth, it wouldn't matter where it landed. The catastrophe would be global. Second, speed. Comets don't move slowly. When a comet enters the inner solar system, it can reach speeds of 70 kilometers per second. That's 252,000 kilometers per hour. At that speed, the kinetic energy of an object is colossal. Basic physics. Energy equals half the mass times the velocity squared. Double the speed, and you quadruple the energy. Comets are fast. Very fast. Third, composition. Comets are made of ice, water, carbon dioxide, methane, and rocky dust. When they get close to the sun, the heat makes the ice sublimate, creating that bright tail we admire so much. But this beauty hides something sinister. The more volatile the material, the more unpredictable the comet's behavior. They can change course, speed up, break apart into smaller pieces, but just as deadly. Now here's the problem. Most of the comets we know are periodic comets. They've been here before. We've cataloged them. We know their orbits. But then there are the others. The long-period comets. The ones that take thousands, sometimes millions of years to complete one orbit around the sun. Those we don't see coming. They just show up out of nowhere. And there's more. Many of these comets come from the Oort cloud, a region so distant that it's almost halfway between the Sun and the nearest star. Out there, trillions of comets float in the dark, waiting for something, a passing star, a gravitational disturbance, to push them inward, toward us. You're starting to see the problem? It's not a question of if, it's a question of when and how big. Here's where things get really disturbing. Most people think, well, space is huge. The chances of a comet hitting us are tiny. And technically, in any specific year, they're right. The odds are low. But the universe doesn't work on the scale of years. It works on the scale of millions of years. And when you zoom out, the picture changes completely. Earth isn't hit rarely. It's hit constantly, just in intervals that, for us, feel long. The Chicxulub crater in Mexico marks the impact that wiped out the dinosaurs. But that wasn't the only one. There are more than 190 confirmed impact craters on Earth. And those are just the ones we can still see. Erosion, tectonic plates, vegetation, everything works together to hide the scars of the past. Here's the twist that goes against everything our intuition tells us. The bigger the object, the less often it appears. But the more certain it is that eventually one will show up. Scientists estimate that an impact big enough to end human civilization happens, on average, every 100,000 years. That sounds far away. But considering that modern civilization is only about 10,000 years old, we are, statistically speaking, inside the risk window. And there's another detail almost no one thinks about. We only started seriously mapping near-Earth objects in the last few decades. Before that, we were basically blind. Even today, with all our telescopes and monitoring programs, it's estimated that we only know about 90% of the objects over 1 kilometer wide that cross our orbit. The other 10%? Those are the ghosts, the unknowns. And the long-period comets? Those are even scarier. Because no matter how good our detection system is, some of these objects are only visible months before they come close to Earth. Months, not years, not decades. In terms of planetary defense planning, that's basically no warning at all. So the question flips. It's not, why should we worry? It's, why do we think we're safe? Let's go back to that image from the beginning. Icy rocks the size of mountains cutting through space at unimaginable speeds. Now you know that this isn't a metaphor, it's literal reality, and you understand that those bright objects crossing the night sky, so beautiful in photos, are actually silent reminders that we live in a violent universe. A universe where the order we experience, stable weather, predictable seasons, a complex biosphere, is a fragile anomaly, held together only by the cosmic luck of us being, so far, in the right place at the right time. The pattern exists. Every few tens of millions of years, Earth goes through a mass extinction. Some scientists believe this is tied to gravitational cycles, maybe the solar system passing through denser regions of the galaxy, disturbing the Oort cloud and sending swarms of comets our way. Others point to dwarf stars that pass close enough to shake the edges of the solar system. What all these theories have in common is this: comets are not occasional visitors. They're part of a cosmic cycle, and we're inside it. But here's the strangely comforting, and at the same time terrifying, part. We know this. For the first time in the history of life on Earth, there is a species that can look up at the sky, calculate trajectories, model impacts, and, in theory, do something about it. Missions like NASA's DART, which in 2022 intentionally crashed into an asteroid to change its orbit, proved that planetary defense is not science fiction. It's engineering. But here's the problem. Asteroids are easy. They're rocky, predictable, slow. Comets are a different story. They're fast, fragile, full of volatile ice. Blowing them up might just turn one big projectile into hundreds of smaller ones, all still deadly. Deflecting them takes time, precision, and, above all, advance warning. And as we've seen, long-period comets don't give us that luxury. So what did we learn? That the threat from comets is not something distant, mythological, or unlikely. It's a mathematical inevitability spread out over time. And even if we're not here when the next big one arrives, the more disturbing question is, what if we are? The scary truth about killer comets isn't that they exist, it's that they always existed, and always will. And the only reason we're still here to tell this story is because, up until now, we've been lucky. But luck is not a strategy, and the universe doesn't care about our plans. Look up at the sky tonight. It's beautiful, silent. But somewhere out there, right now, an ancient piece of ice is speeding up as it falls towards the sun. And maybe, just maybe, it's also falling toward us.